Hello and welcome. This is Scott at MecSoft, and this video presentation will introduce you to some of the very nice pocketing functionality found in RhinoCAM. This demonstration part is an electrical box that will be machined out of solid material. As you can see, there are two pockets in this part, and I'll create three pocketing operations to form these two pockets. To start the machining, I'll choose RhinoCAM, then the Machining Operations browser, which comes up on the left of your screen. You'll notice that I've already created a preliminary facing operation to remove the material off the top of the part, which exposes the pockets so that we can machine them. To create a pocketing operation, I'll make sure that I'm under the Program tab. Then go to Two-Axis option and use the drop-down arrow to select Pocketing. This will bring up the pocketing dialog. Now with this first pocketing operation, I want to machine this very shallow region where the lid of this main pocket will fit. To define the containment region for this shallow pocket, I've extracted curves at the edge of the pocket and then predefined a machining region using those curves. This predefined region will be stored with the CAM data. I have predefined two cutters for this job. I'll use the 26mm diameter end mill for this operation, and I'll load the feeds and speeds that have been predefined with that tool. For the clearance plane, the system will check for the highest Z position of the stock, and I will add 6mm above that for all rapid traverse moves. For the cut parameters, I want the side stock to be 0 because I'm going to finish the walls. I want the cut pattern to be offset cuts, climb cut, and the start point to be on the inside. The step over will be calculated as 40% of the tool diameter. Now for the cut levels, when I originally selected the containment region, I selected it at the top of the wall. This parameter reflects that and must be set correctly. This means that the depth of cut will be interpreted as being below the cut region geometry. I don't know the full depth, so I'm going to use a built-in analysis function that allows me to select 2 points at the top and bottom of the pocket wall, which will then calculate the depth of that wall. Now let's look at the entry and exit. I want the tool to ramp into the material at 15 degrees directly above one of the generated cut segments of the path. For the retract, I'll specify a simple linear retract at 45 degrees. And now I'm ready to generate the path. And there's the tool path for the lid recess. Now, since most of the parameters will remain the same, I'll immediately create another pocketing operation for the main pocket. I will select the new one at the top of the main pocket, and this new region is entered into the containment regions list. I'm going to use the same cutter, so the tool, feeds and speeds, and the clearance plane will all remain the same. Let's take a look at the cut parameters. I want the wall stock to be 3mm so that I can finish the walls later. Again, I want the cut pattern to be offset cuts, climb cut, start point on the inside, and the step over to be 40% of the tool diameter. Now for the cut levels. As before, I selected the cut region geometry at the top of the pocket, so make sure this is set correctly. And I will use the analysis function to measure the height of this wall as well. This is the total depth of cut, and I can break that total depth into roughing and finishing levels. This time, I want a final finishing depth of 2mm at the floor, and that will reduce the remaining roughing depth by that 2mm. Now, this roughing depth can be broken into sublevels. This parameter defines how deep each sublevel should be, and I want them to be 12mm. And let's generate the path. Now, as a good practice, I'm going to rename these operations to be more descriptive. Now for variety's sake, I'm going to create the pocketing operation for the second pocket by copying an existing operation of the same type. I will select a pocketing operation, do Ctrl-C to copy it, Ctrl-V to paste it, then drag the new operation to the bottom of the list and drop it there. And I'll rename that operation. Now I'll edit that new operation. I'll clear the regions list and I'll select two predefined regions as the containment regions, one at the top of the pocket and one at the top of the island. These then are entered into the containment regions list. I will select the smaller tool. I will update the feeds and speeds to that new tool. The clearance plane will be the same. For the cut parameters, the stock will be 0, offset cuts, climb cut, start at the inside, and 40% step over between the passes. Now again, let's define the cut levels. The cut region was selected at the top of the pocket. The full depth has been determined to be 38 millimeters. I want 2 millimeters as a finishing level at the floor, and that leaves 36 millimeters as the total roughing depth. And I'm going to break that up into sub-levels, each of which will be 8 millimeters deep. Because I have an island in this pocket, I'm going to set this Clear Island Tops option. Now I'll generate the operation, and there's the toolpath. I'll simulate this final operation and end the demo here. I hope this demonstration will help you to program pockets in your parts using RhinoCAM by MecSoft. Thank you.